Hello everyone, welcome back to my channel InfoSec Lab, and today we're going to dive into the world of binary files from this is an activity from TryHackMe's Advent of Cyber 2024. The learning objectives of today's room is to understand the structure of a binary file, the difference between the disassembly and decompiling, getting familiarity with multi-stage binaries, and last but not least, practice reverse engineering with a binary file. So, as usual, let's get over some concept first. What is a binary file? A binary file is a file compiled from the source code and which can be executed on a machine. Now, depending on the operating system, a binary file can have different structures. On Windows machines, it has the PE structure, which is portable executable structure on Windows machines. Hence, its extension is often seen as .exe, whereas on Linux machines, the extension for the binary file is .elf, which stands for executable and linkable format. Regardless of the system of the binary files, there are always three components of a binary file, or which is also known as executable. The first one is the code section. This is where the main functions of the file is. The second part is the data section. This is where it contains and store all the information and resources of the file. And last but not least, the import or export tables. These tables are references of the libraries that are imported into the binary file or exported by the file. Okay, so moving on. The difference between the disassembly and decompiling. So when it comes to reverse engineering, there are two main techniques that are often mentioned: disassembling and decompiling. So what are the difference between these two? Disassembling is how do I say that? Disassembling gives you a low level instructions of the binary, meaning that which is written in assembly language. These instructions are mainly for machines interpretation, and decompiling gives you a high level of understanding of how a binary works. Usually, it shows you the language the file is written in, like C++ or C# or JavaScript or Python, etc. So, in short, disassembly, if you want to know how the code works on a machine level, then disassembly is the best approach. Whereas you just want to know the high level, the logic flow on the top level, like what the code or what the executable file actually does, then you can just use decompiling. And then because we are familiar with the programming languages, we can easily get the concept and the logic flow of the binary file. Also, over here, as you can see on the table on my screen, you see on the table we have some other key differences between disassembly and decompiling. Readability requires knowing assembly and low-level knowledge of computing concepts, requires familiarity, whereas the decompiling requires familiarity with the programming language and logic. The level of output of disassembly is translated. The translated output is the exact instructions that the machine will perform, whereas the translated output of decompiling is often as a best guess. The output might not be accurate, and useful information such as the variables, function names, etc. will likely be lost. In terms of difficulty, the difficulty can be considered higher in assembly because of the syntax and then the complex of the assembly language, whereas the machine instructions are translated whereas in decompiling, the machine instructions are translated into a high-level language, which makes it easier to understand if we are familiar with the language the binary is written in. So if we know Java, and then we can understand what it is, or if we understand a programming language, we can from there have the best guess of the application flow, even if we're not familiar with the language it's written in. Usefulness. The entire behavior of the binary can be studied given enough time. So in this assembly, it's a little bit hard because it's down to the low level, so everything has to be like, it's like the atomic level of the instruction. So everything has to be taken step by step, and it takes time. Whereas on the compiling is a quick way to understand some of the logic of the binary. Alright. Moving on, multi-stage binaries. So what are they? In a traditional malware executable file, in a malware file, in a traditional malware attack, there's usually one binary file that performs all the functions or exploit that the attackers want on the target system. But nowadays, attackers tend to split the exploit or their attacks into multiple stages. Usually, and these stages are using multiple binary files, each of which is responsible for a separate function. So in this case, we are talking about two main stages that are widely known. The first stage is dropper. In this phase, the attacker only drop a binary file onto the system, and its main purpose or its main function on the target machine is to enumerate the system information and to gather as much information as possible to see if the target machine is able to execute the payload. If the target machine meets the requirement, then the first binary file in this stage will download the second binary file, which is known as the second stage of the payload. In the payload stage, another binary file is downloaded to the target system, and this second executable file will perform the main attacks that the attackers want to perform on the target machines. And it depends on the scale of the attacks. Attackers can actually split these payloads into smaller multiple binary files for different purposes. Like if you want to only they can have one file only to perform command execution, or they can also have another one to steal credentials on the crypto wallet on the target machines, and then another binary file to perform lateral movement, or installing backdoors on the target system. So it actually depends on the purpose and the intentions of attackers that the payload stage can be split into multiple binary files. So this is known as the multi-stage binaries. Okay. Alright, without further ado, let's get into the activities. That's it for the concept today. So in this demo, we have a file demo app right here. And then there are actually two softwares that we can use today to perform the reverse engineer. The first one is the PE Studio right here. Okay, I already opened that. So what is PE Studio? Let me open this one first. Domain, drag and drop. So what is PE Studio? It's a software designed to investigate potentially malicious files and extract information from them without execution. This will help us focus on the static analysis side of the investigation. Alright, so there are a few things that we have to notice. We need to notice when using the PE Studio. The first thing that when you open the file, in this case the demo.exe, we're gonna have to take a look at the hash values. So this is the very first thing that we have to check, because we want to make sure that the file has not been altered by the time that we investigate or we perform the reverse engineer. So by doing that, these are the hashes for us for the integrity check. Also over here you can see some overall information about the file. The signature is using the Microsoft.NET, so we can infer from this that the file is written in C#. Next, the file type is executable, and then the architecture of the system is 64 bits. And pretty much these are the general information about the demo app. Moving on to the next step, over here we also have in the footprint section, we also have the hashes of the file. These are different hashes. This is SHA-256, SHA-1, and MD5 hash. These are different hash algorithms. And then also here, if you notice, there also a section .text, and then the hash file is hash values, MD5 hash value. So what is it? Usually, as it's been explained right here, the sections represent a memory space with the different content of the Windows executable within the PE format. We can calculate the hash of these sections in order to identify the executable properly. Alright, we'll focus this time on two hashes. The one from the text section right here, which is this one, which is the section on the file containing the executable code. This section is often marked as read and executable, so it should not have any alteration when the file is being copied. We can observe them in the screenshot below, which is here, this one. So every time when we move the files around, we want to make sure that we retain the files integrity, because otherwise it would be no point in doing reverse engineering, because only one small modification, even with one small modification, the application can behave in a totally different way. Okay, moving on to the next one, indicator string section right here. Now these sections provide additional information about the binary file, like the URL, the signature, which we already know, the file name, and then the debug informations. Here at first sight we don't know what the application does, but with the information is provided, like the URL right here, 10.10.10 image /TryHackMe underscore connect.png. We suspect that we may have the general idea that this may be the IP address from the attacker server, and this is going to be the file that is related to this demo application. So with that in mind, we can actually keep an eye on any image file and any activities that related to 10.10.10. Okay, moving on. Now that's it for PE Studio, and then now we're moving on to another tool, which is LI Spy, which is used for analyzing the code on a high level, i.e. we are performing some decompiling we are performing reverse engineering using the decompiling technique. So the same thing, I have already opened right here, IL Spy, and then just open the demo app right here. When you first open the file, it's going to be under this demo section, the name of the executable file. Just expand the section, and then the demo binary, and this is the main functions right here. Okay, so this one is, let's see, let's start with a hello TryHackMe demo binary message, and then there are, okay, so this is the IP address, the one we saw earlier, and then this we have another string of text, which is, now this command is creating a file TryHackMe demo.png on the target's desktop machines. And basically what it does is what this piece of code does is it goes to this URL right here, 10.10.10 /image, and download the file TryHackMe underscore connect.png. And then when the file is downloaded to the target's computer, it is saved under the name of TryHackMe -demo.png, and the location of this file is going to be on the desktop. And once the file has been downloaded and executed, and over here it says that image opened successfully, meaning that once the file has been downloaded, it will be executed or it will be opened by a default program on the target machine. In this case, in many cases, it's going to be the Paint right here. This program, as many of you may have been familiar with. So, and then after the image has been downloaded, executed, there will be a command saying bye bye, leaving the demo binary. So this is, again, because we are doing decompiling, this is our guesses on how the application behaves. Let's see if it actually works in this way. We can try this one, demo, and then hello binary, try me. Okay, cool. So everything has been confirmed. Let's see. I guess it's been cancelled. But as you could see that, there was a hello TryHackMe demo binary message, and then at the end there was also a bye bye leaving demo binary. In between is like it was downloading the file, and then over here you can see TryHackMe demo is opened in Paint. And here on the desktop, we actually can see the file right here. So yes, by executing the binary file, we are able to confirm the behaviors of the application. So that's how you decompile a binary file and investigate its behavior. Okay, moving on to the next one. Let's try performing the same tasks and techniques on this app, WebView app. First, we're going to inspect the app in PE Studio. Just drag and drop. Hopefully it works. You know what? I'll just close and reopen. Oh, it's right here. Okay, as usual, we're going to copy down all the information, take notes during our enumerations. Nope. Okay, so we have the file hash value. We don't have much information about this. Let's go to the footprint. Nothing much going on. Oh, we are opening the wrong file. Oops. My bad. Okay, in the meantime, we try to open this file too. Open. WebView app. Okay, let's see what we get. We get the hash values. We have the size. We don't know what it is written in. So we don't know what it is. Executable architecture. Alright. What else? Okay, let's give it a few more seconds to load. In the meantime, let's go back here. See what do we have. Resources. Fancy app. We have some forms. Okay, the program, application, enable visualize set compiler and text rendering default. Form, okay, looks like it's performing some, okay, this is a function form 1 right here, so we go here. This is form 1. We initialize a component. Okay, it looks like this one is checking for the operating system, making sure that it's running on the Windows machines. So again, this is like the very first binary file on the first stage, the dropper. It will drop onto the system, and if the system is using the Linux, then this binary file wouldn't be working because it's only working compatible with the Windows. So this is one of the example of the stage 1 of the binary droppers. Private boolean is window. Okay, checking if it's window. Time. Okay, looks like it's waiting and then download an executable file right here. Okay, so after waiting, setting timer, so I assume this one would be waiting for a short period of time, and then it will be perform the download and execute file. This is the IP address of the attackers. Okay, explorer.exe. Same thing. It's going to save the downloads onto it's going to download the file explorer.exe and save it into the download folder right here, into the downloads folder on the target system. Okay, and then we're gonna be checking, make sure that the file has been successfully downloaded. If not, then it will show message an error code while downloading or executing the file. Okay. Over here it checks if the file has already been existed. If it's already existed, then it would delete the old file and it would delete that file in order to download the new file. That's why it is. So that's the download and execute file function. Once the file has been downloaded, it's going to start the file, so execute the file. And then once this function is finished, there will be a login form right here, which will login form.text, login form.show. I'm not sure what this is, but let's see. Where's the login form function? Click on that. There's nothing much. So I will assume that when the file is executed, there would be some kind of login form popping up for us. And what else? Initialize a component. I'm not sure what this do. Simply is going to be a simple code where we will source up. Okay, so we have another string where view app resources.test.png. Error loading the image resource. So I would assume that there would be some kind of images over here after executing the file. And over here, let's go back to the main. Okay, the main. Initialize components. Load image from embedded resources using stream execution. Okay, so my best guess is once when the file has been executed. No. The form one right here. Okay, my best guess is over here. Once the file has been downloaded and then executed, there would be some kind of images embedded within the file explorer. After we perform a login, that's my best guess. Let's try it. Double click to run it. Okay. Okay, at this stage, it seems like we need username and password to log in. Can we find the credentials? Let's see if we can find any credentials on the PE Studio. It may help us. So PE Studio right here, the hash values, nothing much. MZ visual, okay, nothing much. The footprints, overlay, MV5. This looks suspicious. We got a flag right here. Okay, we'll take a look at it later. Indicators file. Okay, import flag. We should definitely take a look at this one later. Entry size, header, toolings, protection, subsystem, version, streams, group API tags. Okay, I'll extend it. What do we have over here? It's nothing much. The flags. Over here we have a lot of imports. Anything stands out? Regular. Okay, so it looks like there's nowhere we can find the credentials to log in. So I guess we have a dead end from this approach. So we're going to ignore this for now. Let's try to investigate the other file. The other file. Remember when we execute this WebView app, it automatically download another app from the internet. No, from the server. From the attacker server. Sorry, excuse me. From the attacker server, and the file was explorer.exe, which was stored in downloaded folder. So let's go there and see what it is. Downloads. Right here. We have Explorer right here. Drag. Oh no, not this one. We don't. We want to drag and drop to this one. Let's collapse this first. Which is a lot. Let's drag and drop to this one, Explorer, and then let's see what it does. The files corrected programs. The mains right here. You know, as if you're familiar with programming language, all the functions, everything, all the actions always start with the main function. So if you don't know where to look, just look for the main right here, and then usually it gives you where the program starts. This is usually where the program starts. Okay, Explorer version 1.1 crucial file collector.program. Okay, nothing much. The source. Okay, these are going to be string for the path, get for the path. Okay, this time the second binary file will be targeting the My Pictures folder. So we'll keep an eye on that folder. Searching for files in folder path. Okay, it's looking for the files in My Pictures. We have a text variable. Combine path, get change path. So this will be the name of the folder created by this application when it's run. There we go. See, so over here, this is the name of a new folder that will be created in the current that will be created. Okay, log temporary folder created. Okay, collected files. Directory get files folder search option on that. Okay. So it will search for all the files within that folder. Okay. That's the file name, combine the file name. So basically, I believe what this does is it goes into the My Pictures folder, look for all the items, all the files within that My Pictures folder, copy all of them, and then paste them into the collected files right here. And then once everything is collected and pasted into the collected files folder, then the program will create a zip file called the collected files.zip. Okay, so it looks like this binary is collecting some information on the system. Okay, no files or files matching the expression. Okay, it's just a check. So it copies everything, create a zip file, okay, with the text too, which is collected zip files, collected files.zip. String number 3, okay. Okay, log zip file copy to pictures. Okay, uploading zip file. Okay, we have a function upload file to server. Let's go to this function. Over here we have address. So I would say this is the C2 server. Yeah, the C2 servers. Yeah, I guess this is the C2 server. So if you recall from the previous room, C2 server is basically the attacker servers. So when the attackers compromise a machine, they will send a secret agent and then install that onto the on the target machines, and whatever informations or whatever that secret agent will be performing instructions sent from the C2 server. So C2 server is like the attacker servers that send instructions and then retrieve all the files, all the information from the target machine. So anonymous C2 TryHackMe is going to be the server used in this case. And go back to the main function. Once the zip file has been uploaded to the C2 server, it will delete its track, like delete the file, the zip file. Everything will be deleted, so to leave no tracks. And I guess that concludes the attacks from the attackers. Okay, so I guess that's it. There's nothing related to logging in the vault over here. Remember, when we try to execute the WebView app, we'll be prompted to log in. There will be username and password, and then at this stage I think we are not going on this route to try to log in and see what it is inside the app. We just try to inspect and then reverse engineer on the application, what the WebView app does, and then what is downloaded file explorer.exe does. That concludes the lesson today. Let's try answering the questions. What is the function name that downloads and executes a file in the WebView apps? So in the WebView apps right here, form 1, no, not this one, it was this one, download and execute file. Okay. Excuse me. Once you execute the WebView apps, it's downloaded on a binary in the downloads folder. Okay, that's Explorer. What the domain name is the one from the file it's downloaded after running WebView app? What was the domain name? Was Mayor C2 right here. Okay, the stage 2 binary is executed automatically and creates a zip file comprising the victim's computer data. What's the name of the zip file? Collected files. Zip. Again, it can be found right here. It will create a collected files.zip, and then it will upload this zip file to the C2 server. What is the name of the C2 server? Where was the function? Functions right here. Anonymous C2 dot TryHackMe. So in summary, what this WebView app does is, first it will be executed on the system. It will check if the system is compatible with the file that is running. In this case, it is exe, because if this file is landed on a Linux machine, it won't execute at all. So first, the WebView app will check the system requirements and make sure that it meets the requirements. Once everything checks out, it will download another binary file, which is explorer.exe, and is saved into the downloads folder right here. This explorer.exe file will be automatically executed, which will go into which will gather all the information about gather information about the target system, and then put them all in a temporary file folder. And then once the folder has completed collecting all the information, then the file will create a zip file called collectedfiles.zip and upload that zip file to the C2 server. Pretty much that's how the attack works in this case scenario. I hope you learn more about reverse engineering, the techniques, and then more about the binary files. If you have any questions, especially towards the end of this video, feel free to reach out to me. I'll be happy to help. And thank you very much for watching. I'll see you next time. Bye.